Alright, so we're going to talk a bit about my oscilloscope and how I hooked it up wrong when I did the repair on the Heathkit unit that I had there. So I said that it was both units were Earth's main referenced, and basically I might as well demonstrate that and explain what I mean, and then it'll sort of hopefully come together. So all I could find, I couldn't find my good multimeter. I have this cheap Mastercraft one here, but a multimeter is floating, meaning that the probes are not referenced to anything. So you're simply measuring difference in voltage between the two probes. So we'll turn this on here. Oops. I'll get that on. I don't know how well it's going to show up. But if I just take the one probe here and connect it, this is a 1.5 volt battery. It should brand new. It actually should probably have about 1.6, and there's nothing. However, if I take the ground lead, hook that up, I get both probes and 1.59 volts. And that's because the meter it's floating. It's not referenced to anything, and this battery is also floating. So if I hook it up, the other way, the meter simply tells me I have negative 1.59 volts. So this battery is not referenced to anything at all. So it would be a floating source. Now we come to the oscilloscope, and here's the probe plugged in. The oscilloscope is, I don't have it plugged in, but here's the probe with the ground clip. So if I take the ground clip and I clip it on one of these leads, and I have my multimeter set to measure impedance, now if I take the other end of this probe and simply touch it to the ground probe on the main, as you can see, they're connected. So it doesn't matter. I mean, you can go to the outside as the ground here. So you can check, everywhere there's a ground point, it is referenced back to mains earth here. So it's connected back to this ground prong. And there's reasons for that. It is done for safety. I mean, these probes have a plastic sheathing over them, but a lot of BNC connectors don't. And I mean, you still got the ground bare, exposed there. You don't want to have your oscilloscope hooked up to something and have those floating, so that you could have a potentially lethal voltage there. So now if I'm measuring something with my oscilloscope that's battery powered, there's obviously no problems. I can hook that ground clip up wherever I want to, and that becomes the point that the probe is then referenced off of. Well, in fact, actually the whole oscilloscope. So you do have to be careful if you're using both channels at the same time. Now, most power supplies that you're going to encounter on for small little devices, those wall warts, are usually completely isolated and they're floating. But in the case of this Heathkit digital design experimenter, I'd made note that inside it was connected. So I've got the one probe here will connect up to the power supply ground here. Then I'll take the other lead and I'll just stick it into the ground prong here. As you can see, this unit's been referenced back, so the power supply ground is tied in to this ground prong. Now here's where it gets a little bit more interesting. So this makes perfect sense if you think about it, but what I've done here is I've just taken my probe, still connected back to the oscilloscope here, and I've got the ground clip plugged into one end, and then the other end of my probe I have connected to the ground on here. Now I'm just going to take this power bar and I'm going to plug both units into it, and all of a sudden you see that they are now electrically connected. So essentially during the repair video, when I hooked up the ground probe to the wrong, or the ground lead to the wrong spot there, this is what I effectively did to the unit. I shorted out this guy here, which is why I thought that resistor was dead. Now, like I said, normally I would have been measuring stuff with the would have been probing around with the multimeter first, but I couldn't find my multimeter at that time. Now, because they're electrically connected, the ground and the ground on the oscilloscope, there's actually no reason whatsoever to hook that up. I did it simply because there was a bit of noise at higher frequencies, which is a bit of an issue. But honestly, that's a big no-no hooking up your ground at all because of issues like this. Now in this case, it didn't cause any real damage other than I replaced a part that I didn't actually have to, which is not a big deal. But you can imagine if that if this here was putting out much higher power, it had higher voltage and high currents, and you're shorting it out, you could, I mean, this is just a little wire there. It's not all that heavy of a gauge with a small clip on it. You can easily blow that up, and if you're hooking that up, you know, while it's on, that could actually, you could cause some serious arcing and blow that wire right in your hand and cause some burns. In this situation though, with both things being ground referenced, you're supposed to use a differential probe, but they're expensive and I don't have one. So the next best thing, what you should do then for safety, is simply remove the ground altogether and don't use it. So now as you can see, when I measure with the multimeter, I get not quite 2.5 volts, which is what I expect, because I expect there to be roughly 50% duty cycle square wave there at 5 volts. So the meter should be reading about half of that. And that's what I get. And everything's fine. Now, if instead of having the ground hooked up to the ground on the Heathkit unit, I'm just going to take my oscilloscope probe here, which I have the oscilloscope plugged in as well. And I'm just going to hook the ground lead onto the negative terminal here. Now when I take my multimeter and I hook it up, sure enough, I get the exact same result. So I was shorting that out. And just to show that it doesn't matter where I connect it, I mean, I can hook that up to the 5 volt, and I get, you know, the 5 volts, the minus 12, well, there's minus 12 volts, plus 12, getting plus 12 volts. So that's exactly what I would expect. So now to just further demonstrate my point, I'm going to take the probe here with the ground removed, and if I just take this and I probe that that clock, you can see the waveform comes up and it's perfectly fine. I mean, there is no need for me to actually connect the ground. Now I'll demonstrate what I was talking about here. So I'll hook up the, this is to the clock, not the line source clock, but the one based on the 555 timer. And now as I speed this up, you can see, well, I'll actually speed the clock up more. Now as we zoom in there, you can see that we have a lot of ringing in here. So it looks like we have a noisy circuit. Now what I'm going to do is I'm just going to reconnect the ground probe, and I'm going to hook the ground up to the correct spot, to the actual ground on it. Now you see, if I stick that probe back in there, that ringing is gone. So in all reality, it's not actually the circuit that's ringing, that's just noise that I'm picking up. So what do you do if you can't afford an active probe and you want to take a differential measurement? Well, the answer is you simply use both channels of your oscilloscope, or two of them if you have a 4-channel, and you use the math function. So here we are. I'm probing the line source clock again, and the yellow is the input from channel 1, and I have that hooked up to the line clock, and then channel 2 is connected to the ground. Now, I mean, this doesn't really make much sense in this particular application, but just trying to give you a rough idea. And then you simply do channel 1 minus channel 2 is the math operation, and the purple is the output. Now you can see it looks pretty bad, because now you're picking up noise off of both probes, not just the one. And again, I don't have the grounds connected at all. So I guess the long and the short of it is, if you are going to live on the edge there, and some people, I mean, there's great debates about this online. You look around, some people say just never ever use your ground clip if you're measuring something that's mains referenced, unless you have a floating oscilloscope, which is very rare, without spending huge bucks or getting into the ones that you can run off a battery. Because in that case, the ones that have the optional battery pack, you can charge up the battery and then unplug the mains cable. But if you're going to hook it up, I mean, a simple way is just take your multimeter. If you hook it up to your ground clip and then, you know, you start sticking in there, there's some sort of a voltage coming up. It means that you are going to short things out. Like, oops, we can get a connection in there, make contact. So all those would cause issues. And of course, you got to be careful, because if you're dealing with some sort of a slow clock, or for example, these data switches that toggle, you know, where they're hooked up to, that's what some people will argue, and they are correct. So, you know, measure's okay, but if at some point then, while we're hooked up to the oscilloscope, you get that change, you still have that current, well, you'll have that short, and there'll be some sort of current flowing somewhere that you probably don't want. So yeah, when I did the repair, like I said, nothing, there was no signs that I had, at the time, that anything had gone wrong. There was no arcing or anything when I hooked up the clip, because there was that resistor in there. That's it, I guess, for this time. Hopefully that made sense. And I guess I'll catch you next time. Okay, I had the video actually uploaded, and then I remembered one more thing with your probe. You gotta be careful. Don't be probing anything that is mains referenced, including mains itself. So that means if you have something like a switch mode power supply, yeah, you better be getting a differential probe if you want to start sticking it around in there, because that's where you're going to run into problems, and you got to really watch this ground clip here. If you need to be probing around stuff like that, connect it to an isolation transformer and isolate it. Don't have it be plugged directly into the wall. Use that isolation transformer, and be careful, because if it's grounded, the ground still carries through on most of those isolation transformers. Not really recommended, but I guess it'd be better than just sticking a probe in there, would be to obviously have your equipment under test with an isolation transformer and the ground point to be floating as well. But again, not really recommended. So I'll edit this in, pop this, re-upload this video, and then that's it, I guess. Till next time.